This question is asked in Gate 23 of Instrumentation. This is from Control System Subjects, and we can say from RH criteria topic. The question is the number of zeros of the polynomial P of S in the right plane is how much? Students, you know RH criteria used to find the roots of the equation, right? So the roots of this equation are nothing but the zeros. Okay, if they would have said it's a Cartesian equation, we might have said these are the poles. But it really doesn't matter as far as this question is concerned. In simple words, how many roots of these equations are in the right half of S plane? In other words, how many roots are positive is what the question is asked. So, so by referring the RH criteria table, so let me make the table. The highest power is 3, right? So S cube, you have S square, you have S power 1, you have S power 0. So 1 and 5 are the coefficient, then 2 and 80 are the coefficient. So how much you get here? So you get here 2 into 5, 10, minus 80 into 1, 10 minus 80, minus 70, minus 70 by 2 is minus 35. And this is 0. And next, if I ask you what is this? This into this, minus this into this, divided by this. So this into this is whatever, minus 0 divided by this one. So we are left with only 80. So you get here 80. So the number of roots which are lying on the right half S plane depends on how many sign changes are there, right? There are two sign change. One sign is positive to negative, another is negative to positive. So there are two sign changes are happening. It means that two roots of these equations are lying on the right half of S plane. So this answer has to be 2. In left half 1, right half 2. So answer is 2 for this. This question is asked in Gate 23 of Instrumentation. This is from Control System Subjects and from Nyquist plot topic. The question is the number of times the Nyquist plot encircles the origin is dash. Okay, so we can directly tell this answer using the Nyquist stability equation, which is your n is equals to p minus z. One of the ways you plot the Nyquist plot, and from there you can tell, but that much of thing is not needed for these 1 mark questions. Using this equation, we can tell easily. What this P indicates? P indicates number of open loop poles in right half of S plane. So this P indicates number of open loop poles in right half of S plane. And what this Z indicates? Z indicates number of open loop 0 in left half of S plane. So what is the P value here? P value, number of open loop poles. So these things, I mean, we need this data from the open loop transfer function, which is given. So open loop poles in right half of S plane. So no poles are in the right half S plane. Both poles minus 2 are left half S plane. So number of open loop poles in right half S plane is 0. Number of open loop 0 in the left half S plane is how much? This is basically coming as how much in this case? So this Z value is coming as 2. Sorry students, so here, sorry, this is right half, right? Sorry, right half S plane, right? So number of open loop poles in right half of S plane is nothing but your P. Number of open loop 0 in right half S plane nothing but your Z. So no poles are in the right half of S plane, and two zeros are in the right half of S plane. So your P value is 0 and Z value is 2. So n is equals to 0 minus 2, which is coming as minus 2. So what is the meaning of minus 2? The meaning of minus 2 is that the contour will encircle the origin in clockwise direction minus 2. If the answer could have been plus 2, the difference is, so in plus 2 case, it will be in the anti-clockwise direction, in minus 2 case in the clockwise direction. But here direction related, no ambiguities in these questions. So simple answer is 2. So if you ask me, sir, what is minus 2? It means that it is, encircling that origin twice in the clockwise direction. That is the meaning of, for that clockwise you have this minus sign, for anti-clockwise you have the plus sign. And this is true what I am saying if I assume the contour in the clockwise directions. If I assume the contour in the anti-clockwise directions, so the opposite thing is going to happen. But in the most of the usual cases, we assume it in clockwise directions. With respect to that convention, minus sign indicates encirclement in the clockwise directions. So answer is 2 for this. Very simple. Just by using this equation, we can easily tell the answer is T. Where P indicates open loop poles in right half S plane, Z indicates open loop 0 in the right half S plane. From the open loop transfer function, we can directly access this data and we can easily tell the answer as 2. This question is asked in gate 23 of instrumentation. This is from control system subjects and related to the frequency response topic, or related to Nyquist plot, polar plot we can say, or even Bode plot also we can relate. The question is, the phase margin of the transfer function g of s is how much in degrees? So based on the given transfer function, we have to find the corresponding phase margin. So phase margin is given by the formula 180 degree plus phase of the transfer function at a frequency called gain crossover frequency. So we have to find first what is the gain crossover frequency, and then we'll find the phase angle of this transfer function. So let us find the phase angle. Phase angle of the transfer function is, so if you see the numerator, so this is in the fourth quadrant, so you get minus of tan inverse of omega, and for the second term you get, actually it is in denominator, so you get minus tan inverse omega, but because of the square term you get two terms. So basically the denominator will contribute minus 2 tan inverse of omega. 2 we are getting because of the square factor, minus we are getting because in the denominator. So overall this is coming as minus 3 tan inverse of omega. So my answer will be 180 degree plus, not plus, so minus 3 tan inverse of omega gc, because this phase we have to find at gain crossover frequency. So this is what my answer will be. So here the unknown quantity is omega gc, which is nothing but the gain crossover frequency. What is gain crossover frequency? Gain crossover frequency is that frequency where the gain of the transfer function is basically 1. So if I ask you what is your g of j omega, it is 2 into 1 minus j omega divided by 1 plus j omega whole square. So if I ask you what is the corresponding magnitude g of j omega, so this is basically how much? 2, and this will be 1 plus omega square divided by, so it is 1 plus omega square, because one term will contribute 1 plus omega square root, and again one more term will be same, so if multiply, square root will be gone, so because of the square factor, so you will get this term. So now if we, but we need this, so okay fine, so this is equals to how much? If I simplify it further, so I get this as how much? 2 by 1 plus omega square, right? Yeah, 2 by 1 plus omega square. This is what thing is. But if I say this is the gain crossover frequency, if it is gain crossover frequency, then this magnitude is supposed to be 1. So we are interested to find the gain crossover frequency. So I can say that, so this, if I write omega into omega gc, this has to be 1. So this implies 1 plus omega gc whole square root of it. So this happens to be 2. 1 plus omega gc whole square happens to be 4. Omega gc happens to be square root of 3. So omega gc happens to be square root of 3. So now you substitute omega gc is equals to how much? Square root of 3. So my phase margin is nothing but equals to 180 degree minus 3 tan inverse of root 3. So 180 degree minus 3 tan inverse of root 3 is 60 degree. So this is 180 degree minus 180 degree. So this happens to be 0 degree. So this answer is supposed to be 0. So the phase margin of the given transfer function is 0 degree, right? So simple and straightforward problem, easy one only. So answer is 0 for this. This question is asked in gate 23 of instrumentation. This is from control system subjects and from Bode plot topic. The question is, the magnitude and phase plot shown in the figure match with the transfer function, which of the following? Okay, it's a skill based question answer, students. So you have to be careful while giving the answer of this. I mean, it is not like the user model problem where a Bode plot is given. We used to find the corresponding transfer function by finding slope, number of poles, zeros at various kernel frequency. Not that way. So by observing the plot, it is very clear that, so by observing this magnitude plot, at least I think all of you are confident it belongs to a second order transfer function Bode plot, right? Because this is how the pattern we get for a second order system. So if you see all the 4 options having the second order transfer function, So in fact, this term is I think this term is common in all four options, right? I mean, D having 100, but anyway, the pattern is somewhat very similar to this. So, but from the phase plot, actually the answer is hidden in the phase plot. If you see, student, the phase plot, so you see it is kind of a linearly decreasing pattern. And what is that term which contributes linearly decreasing pattern of phase? So there is nothing but a delay, transport delay, which is in the form of e raised to power minus tau s. E raised to power minus tau s, if you plot its corresponding magnitude is 1 for all frequency and phase is linearly decreasing. So definitely along with the transfer function, this factor should be there so that this pattern will satisfy. We are not getting a perfect line like this because along with this, the transfer function is there. If transfer function would not have been there, if this would have been the case, then the phase would have been a perfect decreasing line like this. But because of the transfer function, so you are getting, like here is something like that you are getting, it is only because of the transfer function. But one thing is confirmed. So because by observing the pattern, this factor must should be there. So if this factor must should be there, option A is gone, option D is also gone because you don't have exponential term there. So answer has to be either B or it has to be either C. So if I'm going with option B, so what is happening? Let us see. And okay, fine. So in option B, so if I ask you what is the phase of this one, so if I say that this is, let's say, G1 of S and this is, let's say, G2 of S, then and the overall transfer function is G of S, I mean that this G of S is product of G1S and G2S. So if I ask you what is G of J omega, so this is G1 of J omega plus G2 of J omega, because phase, if the transforms are multiplied, you can add the corresponding phase. So what is G2 of J omega? So G2 of J omega is nothing but equals to how much? So G2 of J omega is nothing but minus of 0.05 J omega. But if I ask you what is this corresponding phase, so what is the corresponding phase you get? So the phase is nothing but minus 0.05 into omega. Minus 0.05 into omega. So G2 of J omega, its corresponding phase is minus of 0.05 omega. So let us say that we are finding its corresponding phase at a frequency 100. I mean, how much phase is contributed by this transfer function at frequency 100? Why I am taking 100? Because you can take any point. Actually, you can take any point for reference. So I am taking 100. So the one of the region is calculation will be easy. So it is minus 0.05 into this is how much? 100 means okay, you have to substitute 100. So this, if you check it, so this is coming as how much? Minus 5 radians, right? Minus 5 radian, because radian per second and second here, so it is basically radian. So minus 5 radian is how much if you convert into degree? So this, if you check it out, so it is coming as minus 287 degrees. So minus 287 degrees it is coming. So G of J omega, so if I ask you what is this phase at a frequency, I mean this phase at a frequency omega equals to 100. So one thing is confirmed, like this part will contribute minus 287 degrees. And rest of that part will be contributed by this G1 transfer function. Summation of this should be somewhat in the range of this minus 360. Summation of this will be somewhat in the range of this minus 3, because at 100 if you check the overall transfer function phase, if you see, so this is, I mean this part you see somewhere around 360, 370 it will come that place. Okay. So that is what we expect. So answer has to be, because answer has to be in option C. So this phase contribution, if you check, because this 10 raised to power minus 12, it will be very, very negligible. Okay. So in that sense, logically it means that B has to be the answer, because if you see, imagine a case here, if I am writing here into 10 raised to power minus 12, so this will be almost 0. And if it is almost 0, whether only the second order transfer function can contribute this minus 360? Impossible. Yes or no? So answer has to be option B, because we know that at max this transfer function will contribute how much? Minus 180. That is what the maximum phase that this can contribute. So if this part is not contributing significantly like in this range, overall will not be this 360, 370. So in this case, so from the transfer function, because overall we are expecting 360, 370. So in the transfer function, we are expecting in the range of 90 degree. I mean minus 90 degree. If the transfer function contribute minus 90, it is fine. But if you go with option C, so this is almost zero, right? Because if you are multiplying 10 raised to power minus 12, it is almost zero. If it is almost zero, whether can this be giving minus 360, 370? Only the transfer function? Not possible. And we have already said that A and D cannot be the answer. So we are ruling out option C also logically, and answer has to be option B. If you want you want to satisfy yourself in a more calculation way, then you simply find the transfer function in the phase of the transfer function at frequency 100, and you check it out. So you'll be definitely getting it is it is almost close to minus 90 degree, and if you check it, it will be coming in the range of minus 37, which is perfectly satisfying this criteria. So answer has to be option B for this. It's a good logical question, students, right? So I like this question because using your skill by observing the option, you have to tell the answer rather than going into too much of calculations. This question is asked in gate 23 of instrumentation. This is from control system subjects and related to root locus concept. The question is, consider a standard negative feedback configuration with G of S and the controller C of S. The root locus of GS/CS is presented in the figure below. The gain C of j omega is 2 at a frequency omega equals to 1 radian per second. The value of KD is, okay. So we have a transfer function G of S and a controller transfer function, which is a PID controller transfer function given. So the root locus is product of GS and CS. I mean the transfer function for what this is given is for this one. So we are supposed to find the gain KT. Okay, and provided if the gain of this is 2 at omega equals to 1 radian per second. So let us see. So students, so this C of S, if I take LCM as S, so I get this as KPS, isn't it? KPS plus KI plus KD S square plus KD S square. So the if I ask you what is this G of S into C of S, so this is your KPS. Okay, let us write in this way. You can write this as your KD S square plus KPS plus KI. Okay, this divided by S. And the GS transfer function is 1 by S minus 2 into S minus 3. So here you get S minus 2 and here you get S minus 3. So for this transfer function, for GSCS, the root locus is given. And one more data is given is that C of j omega is equals to how much? 2 at a frequency of, this is 2 at a frequency of 1 radian per second. Okay, so we are supposed to find the value of KD. So KD is unknown. So how do you find it? So students, see here, one simple observation. If you observe that a pole is moving in this direction, okay, and you can see there is also a movement in this direction. It means that there are two zeros. One is one pole is moving in this way, one pole is moving this way. So definitely there are two zeros because poles ends at 0. There are two zeros. And what is the location of this 0? If you check it, the location is minus 1. This 0 is existing at s equals to minus 1. So definitely in this overall transfer function, in this GSCS, the numerator having a factor of s plus 1 whole square. Why? Because 0 are existing in the numerator and there are two zeros. Where? At minus 1. At minus 1, that's why s plus 1. How I am knowing 2 0? Because of this arrow marks. There are two arrow marks approaching to the 0. That means there are two poles. One is coming from this way, one is coming from this way. So if I expand this s plus 1 whole square, I get it is s square plus 2s plus 1. S square plus 2s plus 1. Now by making the comparison, What I can tell is KD corresponds to 1, KD equals to 1, KP if I check, KP equals to 2, KI if I check, KI equals to 1. So your KD is 1 and your KP is 2 and your KI is basically 1, isn't it? So we are supposed to find the answer of KD. So KD is 1, very simple. And you may think, what is the use of this data? So we can cross check also, no problem. You can see, so C of S is given as how much? KP plus KI of by S plus it is how much? KD into S, KD into S. So now if I substitute here, how much? If I substitute here, what is that data is given? That at omega equals to 1. So if I substitute omega equal to 1, so S equals to J omega. So omega equals to 1 means S equals to J into 1. So that is basically J. So this is KP. KP value is how much? 2. So KP value is 2. KI value is 1. So it is 1 by J. KD value is 1. So 1 into J. So you can see it is 2 and this is minus J plus J. So we are getting it is 2. So that means these gains, what we have got here, KP, KD, KI. So you can see by substituting there, and by substituting omega equals to 1, we are getting the answer as 2. So C of S magnitude is basically 2 at a frequency of omega equals to 1 radian per second. So student, you may think why this data is given. Why this data is given means, so in general, there might be a possibility of a gain factor K also. So now we are confirmed that the value of K equals to 1. Suppose if this would not have been matched, so accordingly we have to see what would have been that K. So K is basically 1 in this case. So for that purpose, this data is given and we confirm that yes, the K is very 1. So what is the derivative gain KD? The answer has to be definitely 1. So 1 is the right answer for this question. It's a good question, good logical question, right?